This was the very first question I showed you before, on which I argued you've been using these inverse trig functions for a while, you're used to them, what's the big deal? Okay. Now, can you rehearse for me again, what was the working out that we showed? What would be the very, very first line if we're trying to find theta? In this case, I've actually gotten rid of one sine. So I think I used sine, didn't I? I said sine equals this. Okay, now usually you would go straight to your calculator, but we included a line of working to clarify what was going on. What was the next line? Theta equals sine inverse, right? Okay, and then you get your calculator out and it's fine, okay? But there's an unspoken assumption going on here. Do you remember I said before, you've learnt all this new stuff, we need to account for it, but there are also nuances in what's going on here that we have ignored, okay? You have all assumed, fair enough, because you've been told to, that to go from here to here, what has happened? What have you done to both sides? You have taken sine inverse of both sides, right? You are assuming this. Now that is a reasonable assumption to make, okay? Because in all of the equations you've been working with so far, you have learned if you do something to the left-hand side, you do it to the right-hand side, and everything will be okay, right? Except there's a problem, okay? Is this really true? Is this really true? I want you to think about the way that we've defined sine inverse and this line, and why there is a problem. This is very, very tricky, okay? Let's just try some values out. I actually want you to get your calculator out with me and just see what happens. Get your calculator out. This is what I'm trying to test. Does sine inverse of sine theta, does it really equal theta? Okay? Now, remember we talked about kinds of proof before we were looking at induction, right? I'm going to be a little scientific here, okay? I'm just going to experiment. And I'm going to repeat some observations, okay? So for instance, let's have a go at, well, this one's a bit meaningless. Let's try one which is simple. Let's go sine inverse of sine 0. Now, if we're following this pattern, you should expect 0, right? Make sure you're in, actually it doesn't matter. Put it in radians just in case. But when you put in sine inverse of sine 0, what do you get? Okay, so far so good, okay? Let's try another angle, okay? I think from memory this was 37 degrees. Sine inverse of sine 37 degrees. What do you get? Oh, I just told you to put it in radians, didn't I? That'd be like 0. I don't know, 6 or 7 or something like that. What do you get? Sorry, I put 0.6 in, right? Did you get that back? Okay, so far so good. Let's try another angle. Let's go a little bigger this time. Let's go say, I don't know, pi on 2. Sine inverse of sine pi on 2. What do you get? You get 1.57 blah blah blah. You get pi on 2, no problems. Okay, let's just keep going. Sine inverse. Let's try an angle like pi because I know what sine pi is, right? What does your calculator tell you? Hold on, just check it. Maybe you're doing your calculator wrong because you know, I do my calculator wrong sometimes. You put your numbers in wrong. You be careful with your brackets, all that. Are you sure? So you know there's Mythbusters, right? I call that busted. Except it's only part busted, isn't it? Because it seems to work sometimes. And then it breaks down here. Is this the only place it breaks? No. Come on, let's be scientific. Let's try something else. Give me another angle. 2 pi. What do you get? You get 0. Huh. Let's try a more interesting angle. Let's try, say, 3 pi on 2. Because that's a little less boring than pi on 2 pi. What do you get? What do you get? You get negative 1.57, which is negative pi on 2. Now hold on. What's going on? Okay? It's not like it works, and then it just gives you 0, right? It works, and then it gives you weird stuff. What's going on, right? Can you work out what's going on? So, this is why I had to leave this on the board, okay? What's the domain of sine? What's, not a trick question, what's the domain of sine? It's, well, regular sine, it just goes forever, right? So I can stick anything I like in here. Doesn't matter how big, how small, and it will accept it, okay? But when sine inverse gives you back an answer, right? It is restricted, right? So no matter what angle you stick in here, you will only ever get something between minus pi on 2, negative pi on 2, and pi on 2. That's what all of these fit, right? That's as far as you can go, okay? That far and that far, right? So sine inverse of sine theta doesn't always equal theta. Where does it equal theta? It only equals theta in this place that we've restricted it, because we restricted it, right? So therefore this is true for this, which is why, whoops, theta. This is a nuance which we could have safely ignored for questions like this. Can you see why? You can ignore it because I'm in a right-angled triangle. A right-angled triangle. So whatever these two angles are, they must be acute. And that's why you, as a year 9, could ignore this, right? But you're not in year 9 anymore, okay? Now, there's a restriction on that. Let me pose the next obvious question to you. We've just said you can't just do sine inverse of sine and just expect it to work out, okay? Well, these are inverse functions, right? They reverse each other. They should be mutually inverse, right? What would you expect to make of that? You think about it. Some of you may actually well know the answer, to which my question to you would be, can you explain why? We've just explained why. This has a restriction on it. Does this work? Does it work all the time? Does it not? If not, why not? And if so, where? Okay. What's it equal to? And how can you argue it? Okay.